So using the simplifying assumption that x is negligible, the denominator just becomes 0.5. And I apologize, I have the same typo here. It's not 543, it's 0.534. So what we're going to do, this is just the basic algebra. We're going to multiply both sides by 0.534. And the 0.5, the terms are going to cancel. This is 0.534, fixing my typo. 534. That's going to cancel. And then we just have that 0.534 times 1.8 times 10 to the minus 4 equals x squared. And that is 9.6 times 10 to the minus 5 equals x squared. To get to x, I take the square root of both sides. So the square root of 9.6 times 10 to the minus 5 equals the square root of x. And x then equals 9.8 times 10 to the minus 3. So now I have the value of x. So I'm not asking you to do this, but you can, this assumption, the simplifying assumption that we made that x was very small, if we say 9.8 times 10 to the minus 3 divided by 0.534, that's 1.8%. That's less than 5%, so it's a valid assumption. And this x is 9.8 times 10 to the minus 3. That is a molar value because this is we started off with concentration in moles. So x 9.8 times 10 to the minus 3 is our concentration of formate. It's also our concentration of hydronium ions. So pH is equal to the negative log of the concentration of hydronium ions. So pH is equal to the negative log of 9.8 times 10 to the minus 3, or pH is equal to 2.01. And you see the mantissa has two significant figures because the value of x has two significant figures, and you might be wondering, how did we get to two significant figures here? This one's 3. Well, if we go all the way back to the Ka value that I gave you at the start, the Ka is two significant figures. So when we set up this expression with Ka, it's this two significant figures that determines our final answer is going to have two significant figures, or two significant figures in the mantissa. Now, the second part of the concentration, or of the question, was, it said, what is the concentration of the hydronium ion? So we got that concentration of hydronium ion. And then what is the pH of the solution? And we got that. So those are our two answers. Now, in the post lab, we have question 8 and question 9. I'm not going to work these for you. You can come to office hours, or you can contact me and we can set up an independent time to talk. But it's basically the same process using an ice table. There are 2 mils of buffer per well. You're asked to calculate the final pH of the undiluted buffer. So you're not taking into consideration that you're changing the volume by the addition of these drops. So that's also a simplifying assumption. You're given the Ka. You calculate your buffer concentration, and then In question 9, you're given a similar type of problem. What's the final pH of the second dilution after adding 1 drop of 0.1 molar sodium hydroxide? An important thing that you need to know, and this was in the video of my colleague, Dr. Kavalt, you assume that 20 drops equals 1 milliliter. Now, for grading in the lab, I want you to treat this as an exact number. Don't give me one significant figure because of this. Treat this as an exact number. But this is generally true. If you get a eyedropper and you measure the volume or you weigh 20 drops and you do this, 5 times or 10 times, on average, 20 drops will be 1 milliliter. And this is true because the surface tension of water, that the drop will only get to be a certain size before it falls. The surface tension will hold it in place until its mass becomes a certain mass related to its size, and then it drops. If you squeeze the bottle such that a stream of drops comes out, then this assumption isn't true. So don't do that. When you're measuring drops, let the drops form and fall. Don't squirt it. Now, if you're measuring the volume in a graduated cylinder, that's a different case. But when it tells you to add 1 drop, let the drop form and fall naturally. Don't over-pressurize the bottle to have a stream come out, because then these volume assumptions aren't going to work out. Okay, that's all I have, and feel free to get in touch with me if you're having any trouble with these calculations.